Our atmosphere serves both as a resource for nutrients and as a depository for waste. For example, photosynthetic plants take in carbon dioxide from the atmosphere as a nutrient and expel oxygen as waste. Animals that utilize oxygen give off carbon dioxide. However, humans have the ability to add extra waste to the atmosphere that we call air pollution. Air pollution is the addition of chemicals and/or particles to the atmosphere in concentrations that are harmful to life on Earth. Let's consider a few of the major air pollutants. It's important to note that these pollutants are naturally added to the atmosphere all the time. It's just the excess addition by human processes that causes serious problems. Sulfur dioxide and nitrogen oxides are reactive gases that damage buildings and plants and can also increase respiratory problems in humans. They are emitted from the combustion of fuel, such as a coal-burning power plant, and nitrogen oxides are also heavily emitted from automobile exhaust. Particulate matter refers to small, solid, or liquid particles that are released from many natural sources, such as fires, dust, and volcanic eruptions, but are also emitted by humans during construction and industrial processes. PM 2.5 and PM 10 refer to the size of these particles. Another major pollutant is carbon monoxide, which is toxic to humans and other animals in low concentrations, given that it reduces oxygen circulation in the body. Carbon monoxide is mostly emitted from automobile exhaust. All of these pollutants so far, sulfur dioxide, nitrogen oxides, particulate matter, and carbon monoxide, are all considered primary pollutants. That is, pollutants that are released directly into the air. Now let's consider a secondary pollutant, ozone. Environmental scientists talk about ozone at two regions in the atmosphere. Ozone in the upper stratosphere is very helpful in blocking ultraviolet radiation that we'll talk about later. However, here we're talking about ground-level ozone that is harmful to respiratory systems, plants, and animals. Ozone is a secondary pollutant. A secondary pollutant is produced when primary pollutants react with other atmospheric chemicals. With ozone, for example, this can occur as nitrogen dioxide is released from automobile exhaust as a primary pollutant and reacts with oxygen and sunlight in the atmosphere. The result is the formation of the secondary pollutant, ozone. Now let's look at some other air pollution processes. In urban areas, air pollution is dependent on emission rates, topography, and weather conditions. For example, let's consider a city located in a low valley. This city burns coal and thus releases sulfur dioxide and particulate matter into the air. Because of the low wind conditions in this valley, these pollutants have nowhere to go and thus build up above the city over time. This can create long-lasting smog. These conditions are further exacerbated by temperature inversion. Recall that normally we think of the atmosphere as getting colder with height from the Earth since air pressure decreases at higher altitudes. Yet with a temperature inversion, these conditions are switched. Cloud cover and pollution in the atmosphere block solar radiation from the sun, creating a warm layer of atmosphere above the cooler city below. This temperature inversion traps the pollution near the city, continuing the problem. Smog and temperature inversions occur in many cities all over the world. Another environmental problem caused by air pollution is acid rain. Acid rain is precipitation in which the pH is below 5.6. Recall that pH describes how acidic or basic a solution is by measuring the concentration of hydrogen ions. Natural rain is slightly acidic at 5.6 because of the reaction between water and carbon dioxide in the atmosphere. Acid rain is produced when emissions of sulfur dioxide and nitrogen oxides are transformed into sulfate or nitrate particles that combine with water vapor to form sulfuric and nitric acids. This produces rain that is very acidic and can damage soil, vegetation, and ecosystems, since plants and animals can only survive under certain pH conditions. Today we've talked about major air pollutants and air pollution processes. Next we'll look at what can and has been done to fix or reduce these environmental problems.